Hello students, in this video we are going to discuss about the small sample test. Here small sample test, it is also known as a t-test, right? So before we'll start with the problem based on a t-test, firstly we need to understand about the t distribution, right? In case of the large sample test, we are using the normal test, which is based on the normal distribution, z distribution, which is also a normal distribution. So small sample test, it is based on the t distributions, so hence the name as a t test only, right? So firstly I'll just brief you about the t distribution. Firstly, basically in t there are two different type of the t distributions. One is named as a student's t distribution, second one is the Fisher's t distribution. Although there is not much difference in the probability density function formula, but how the derivation part is different in both the cases. So I'll just give you an idea about the both the distributions. So firstly we'll discuss about the student t distribution. So if let xi be a random sample of size n has been drawn from a normal population whose mean is mu and variance is sigma square, then the student t statistics is given by t is equal to x bar minus mu upon capital S upon square root of n, where x bar is a sample mean and capital S square is the unbiased estimator of the population variance. So this statistics will follow student t distribution with n minus 1 degree of freedom, and its probability density function is given by here it has a n minus 1 degree of freedom and it is denoted by nu. This is the symbol nu, okay, and its probability density function is given by 1 upon beta 1 by 2 nu by 2 1 plus t square by nu raised to the power minus nu plus 1 by 2, where the value of t varies from minus infinity to infinity. So basically the t distribution is somehow look like a normal distribution only, but it is also a symmetric distribution, but it is more peaked than the normal distribution, right? And in this case its value, the nature of the curve depend upon the degree of freedom. When the degree of freedom are very large, then the t distribution behave like a normal distribution only, okay. So here the notation beta 1 by 2 nu by 2, so beta mn is coming out from the beta function, which has a relation with the gamma function, as beta mn is gamma m into gamma n upon gamma m plus n. And there is one important note that t square upon n minus 1, because it is considered as a ratio of 2 chi-square distribution with 1 and n minus 1 degree of freedom, so it follow beta 2 distribution that we have discussed in the chi-square distribution video, that the ratio of the 2 chi-square distribution will follow beta 2 distribution with, if it has a degree of freedom say n1 and n2, then it is n1 by 2 and n2 by 2. So because it's a ratio of 2 chi-square distribution with degree of freedom 1 and n minus 1, so it will follow beta 2 distribution with degree of with parameter 1 by 2 and n minus 1 by 2. Okay, so in case of student t distribution, t square upon n minus 1, we are calculating this particular parameter and it is considered as a ratio of 2 chi-square distribution, means t square upon n minus 1. This is basically the ratio of 2 chi-square distribution with 1 degree of freedom and n minus 1 degree of freedom. It is the ratio, and it will follow beta 2 distribution with parameter 1 by 2 and n minus 1 by 2. But in case of Fisher's t distribution, it is a ratio of the standard normal variate to the square root of independent chi-square variate. In this case t will follow, it is equal to the ratio of the standard normal variate z, where z is a standard normal variate with follow normal distribution with mean 0 and variance 1, divided by the square root of chi-square variate with divided by its degree of freedom, say n degree of freedom, right? And so this particular one will follow Fisher's t distribution. And if you just look at the probability density function, then the formula of probability density function is same, but the only difference is in this case the degree of freedom is n, because we have considered here chi-square variate with n degree of freedom. So in this case you can see here, if I replace in this formula nu by n, then the formula is same here also basically. Okay, so here I miss, the formula is 1 upon square root of nu beta 1 by 2 nu by 2 1 plus t square by nu power minus nu plus 1 by 2. Okay, so here it is square root of n, because here n is the degree of freedom. So what will happen in this case, t is the ratio of standard normal variate upon square root of chi-square distribution upon n degree of freedom. Okay, so this is how we can define the t distribution here. And one important note is that student t is a particular case of Fisher t distribution, because in this case we have directly considered here a chi-square distribution, but in that case we will consider ns square upon sigma square, which is one of the estimate we are using for the hypothesis testing, and we find out there that it will follow chi-square distribution with n minus 1 degree of freedom. So because that's the reason it is a special case of the Fisher's t distribution only. Okay, now come to the part of, this is basically the difference in the two different type of the t distribution. One is the student t distribution and Fisher t distribution. Now come to the part that how we are going to solve the problems based on the t test or the small sample test. So the main supposition about the small sample test is that the parent population, that means from which the sample has been drawn, it must follow normal distribution. This is the first condition for the testing of hypothesis. Whenever we perform the parametric test, then the first condition is the sample should always drawn from the normal population. So in this case we are assuming that the sample has been drawn from normal population with mean mu naught, and this is one of the way. The second one is hypothesis testing, is we can say that there is no significant difference between the hypothetical value and the actual value. So in this case because for t small sample test we are going to use this same kind of testing of hypothesis which we have used for large sample test. For large sample test we have discussed the two different type of the test, test for a single mean, test for single mean, and the test for difference of mean, test for difference of mean. And I already told you that whenever we perform the testing of hypothesis, the formula is the estimate statistic minus expected value of the statistics upon square root of the variance of t. So in case of small sample test, our statistics z is replaced with a t, so I can denote the estimator with say t1. So in this case our t statistics is denoted by, it is the estimator minus expected value of the estimator divided by the square root of variance of t. So in this case, because t1 is a sample mean, so x bar, its expected value is mu only, and because the variance of x bar is equal to sigma square upon n, right? But because in case of small sample test, the condition is that the population variance is always unknown. This is the necessary condition for the small sample test. So because the population variance is unknown, so we are going to use its unbiased estimator, that is capital S here. So that's the reason here the formula is replaced with capital S upon square root of n, because if you, we already know that the expectation of s square, that is a small s, where small s square is 1 upon n summation xi minus x bar whole square, its value comes out to be n minus 1 upon n times sigma square. So when we take this factor on the other side, so we realize that n s square upon n minus 1, this is equal to sigma square. So because of the definition of unbiased estimator, we know that if the expected value of the statistic is equal to the population parameter, then the estimator is an unbiased estimator. So we name it as a capital S square. So what is the capital S square? It is n small s square upon n minus 1. So this is the relation between small s square and capital S square also. Okay, so sometime for calculating the statistics, so we can also use the formula like x bar minus mu upon small s upon square root of n minus 1, because in certain cases the sample standard deviation is given there, then we can use this particular formula also. Basically we are using the notation of the fundamental uh, of mathematical statistics book from by S.C. Gupta. So in this particular book they have used the notation of small s as a standard deviation, sample standard deviation, and capital S square is basically this is 1 upon n minus 1 summation xi minus x bar square, because in certain standard book they are using capital S square as a sample variance also, but in this particular book that which we are referring here, in that book they have used small s as a sample standard deviation and small s square as a sample variance also. So we are following only that particular notation in this particular part also, right? Okay, so what are the assumption for the student t-test? First one is the parent population from which the sample has been drawn is normal. Second one is the sample observations are independent, and this is the most important point, is the population standard deviation is unknown. That means sigma is unknown. This is the necessary condition for the small sample test. Okay, so when we use the small sample test, the thing is when the sample size is less than 30, then we use small sample test, but the another condition is that population standard deviation should be unknown. If the population standard deviation is known, then we can use simply the formula for, in this case we are using simply the formula as x bar minus mu upon sigma upon square root of n, because we are using capital S as a unbiased estimator, S square as a unbiased estimator of sigma square. So if sigma is known, then we preferably use this particular one only. Okay, now let us come to the problem based on the small sample tests. And the very first problem is, okay, let's start with the problem. The question is, the mean weekly sales of a soap bars in a departmental store was 146.3 baht per store. After an advertising campaign, the mean weekly sales is 22 store for a typical week increased to 153.7 and showed a standard deviation of 17.2. Was the advertising campaign successful? So firstly we just note down whatever the information is known to us. So it is given as the mean weekly sale of soap bar in a departmental store. That means the mean weekly sale means this is the population mean is given here. So the population mean is given here 146.3. Then what will happen? They have conducted some advertising campaign, and after the advertising campaign they have taken a random sample of 22 stores. So what is the sample size? So the sample size is 22, and they find that the weekly sale, that is the sample mean, is 153.7 with a standard deviation, means sample standard deviation is 17.2. So you will find out here the difference that the population mean is 146.3 and the sample mean after advertising campaign its value is increased. But we want to check that either this difference is significant, means on the basis of this data can we say that the advertising campaign successful, means can we say that the sale of the soap bar increase or not. This we want to test in this particular problem. So we start with the first step is set up null and alternate hypothesis. So what will be the null hypothesis? So null hypothesis means no change. So in this case we are assuming that even after advertising campaign there will be no change in the average value. So it means that its value will remain 146.3 only. So what does it mean? It means that the advertising campaign is not successful. Advertising campaign is unsuccessful. Okay, and what about the alternative hypothesis? Alternative hypothesis is, in this case we want to check that the advertising campaign is successful, so we are expecting that the value is average sale is increased. So it means that this is a, it means advertising campaign is successful. So basically it is a right tail alternative. This is a right tail alternative. Okay, what is the next step? The next step is the level of significance we need to decide. So let us suppose we are considering the level of significance alpha, because it is not given in the question, so we are considering alpha as a 5% only. Now because in this case the sample size is less than 30, and second thing, the population standard deviation is unknown, sigma is unknown, and the sample size n is less than 30, so we are using here small sample test. Okay, so it means we have to use t distribution at the given level of significance and the degree of freedom. So in this case, what is the degree of freedom? The degree of freedom is n minus 1. What is n? N is 22, so 22 minus 1 is 21. Okay, so we need to check the value of t. Now it is a right tail. If you just look at the t table, let me show you the t table. So you are given the t table in the form of a right tail only. You can see here the value of t started from 0.50. That means 0.50 means 0.50 is the probability, 0.75, 0.80, 0.85, 0.90, 0.95, 0.975, 0.99, and up to 1. Okay, so it means this is the probability. So we are given only the right hand side part only. So if we want to apply the left tail test, then we simply multiply it with a negative sign, because the t distribution is symmetric like a normal distribution only. Okay, so here we need to check the value of t at 5%. What does it mean? 5% from the right hand side. So it means that if this is the t distribution curve, so 5% we are going to reject from the right hand side. So this is 0.05. Okay, so it means that I need to check the probability t is greater than t naught is equal to 0.05. So right hand side is the region of rejection. Okay, so we refer this particular table. So because we are considering one tail and 5% level of significance means, that means the probability is 0.95. If I say that up to this it is a 0.05, it means that up to this point the probability is 0.95 only. Okay, so from this table, what is the value of t at 21 degree of freedom? 21 degree of freedom. Okay, 21 degree of freedom. And we need to check the value at 5% level of significance right tail. So it means that its value comes out to be 1.721. So what is the value? 1.721 at 21 degree of freedom and 5% level of significance. So what is the tabulated value? It is 1.721. So it means that if the test statistics value is greater than 1.721, we are going to reject the null hypothesis, right? So the next step is we need to calculate the test statistic. So what is the test statistic? So the formula of t is x bar minus mu upon capital S upon square root of n, and because in this case we are given small s, so we can use the relation x bar minus mu upon small s upon square root of n minus 1. Like I told you that we have this relation for with capital S and small s, that what is capital S square? This is equal to ns square upon n minus 1. So s square upon n is equal to s square upon n minus 1. So if I take the square root of these, then this is capital S upon square root of n is equal to small s upon square root of n minus 1. So we can use this relation here. So if we substitute all this value here, so what do we get? The value of x bar is 153.7 minus 146.3. The value of s is 17.2 divided by square root of n minus 1 is square root of 21. So this is equal to, it is 7.4 upon 17.2 multiplied by square root of 21. So to calculate this value, we can use a calculator. So the value is, if we calculate this value, 7.4 multiplied by square root of 21 and then divided by 17.2. So its value comes out to be 1.97. So 1.97. So you can see here the tabulated value is 1.721. Okay, so this is the value this is the critical value 1.721. Critical value means which separate the region of acceptance. This is the acceptance region and this is the region of rejection. This is the region of rejection. Okay, so you can see here 1.97, it falls in the right hand side. Okay, so it means that this value falls in the region of rejection only. Okay, so because the calculated value, because t calculated, which is 1.97, it is greater than the t tabulated value at 0.5% level of significance and 21 degree of freedom, that is 1.721. So it means that t calculated falls in a region of rejection, falls in the region of rejection, hence null hypothesis rejected. Hence null hypothesis is rejected. Okay, if null hypothesis is rejected, so what can we conclude? So null hypothesis means advertising campaign is unsuccessful, means there is no change in the weekly sale of the soap bar. So it means that, so we can conclude, what is the conclusion here? The conclusion is advertising campaign is successful. Means there is a significant difference in the hypothetical value and the calculated value. So advertising campaign is successful. Okay, although the difference is visible here, so but with the help of this testing of hypothesis, we want to check that either this difference is significant or insignificant. Okay, so on the basis of this particular data, what we conclude that there is a significant increase in the sales, so hence the advertising campaign is successful. Okay, let us come to the next question. Okay, so in this question we are given a random sample of 10 boys had the following IQ. Do this data support the assumption of the population mean IQ of 100? Find a reasonable range in which most of the mean IQ value of sample of 10 boys lies. Okay, so in this particular case we want to check that, so we are given a data of a 10 student and their IQs are given, means in this case sample mean is not given, means we are given the value of xi. So it means that with the help of these values we need to firstly calculate the sample mean. 120, 110, 101, 88, 83 and 95, 98, 107 and 100. Okay, so firstly with the help of this data we need to calculate the value of sample mean as well as the sample standard deviation, because the population standard deviation is unknown. In this case again sigma is unknown and we are given here the sample size is 10, so n is less than 30. So it shows that we need to apply here the small sample test. Small sample test, right? Okay, so for calculating the sample mean and the sample standard deviation, so let us use the Excel. It will minimize the computation part. So let us consider this Excel here. So if I simply take this particular data, the value of x is 70, 120, 110, then 101, then 88, then 83, then 95, then 98, then 107 and then 100. So we are given the 10 observations. So with the help of this 10 observation, let us firstly calculate the mean, sample mean. Okay, so what is the sample mean? So sample mean is the, what is x bar? So x bar is summation xi upon n. Okay, so we simply sum up all this value and divide it by, and so we can use the formula of sum. Okay, so otherwise with the help of calculator we need to add up all this number. Okay, so its value comes out to be 972. Okay, so this is the value of sum, right? So what is the mean? So mean value is this value divided by 10. So sample mean comes out to be 97.2. Now we need to calculate the variance. So what is the formula of variance? There are two ways. So s square can be calculated as 1 upon n summation xi minus x bar square, or I can write 1 upon n summation xi square minus x bar whole square. So in this case, because mean is not the integral value, so I firstly calculate the value of x square, right? So I simply take the square of all these number, and then we can extend the formula of this one, so its value comes out to be this, and then we can calculate the formula as, what is the formula of sample variance? This is equal to 1 by 10, or this number divided by 10, I consider it in the bracket, minus mean square. Mean square means minus this square. So it will gives us the value of the variance as 183.36. okay, so their sum is this, so its value variance comes out to be this. Otherwise I can directly use the formula of variance also in the in Excel we have a direct command of variance also, so its value is 183.36, but manually this is how we can calculate this, right? So mean value comes out to be 97.2. So mean value comes out to be 97.2 and variance comes out to be 183.36. okay, so we can calculate the value of standard deviation is a square root of 183.36. so we can refer the calculator as well. So the square root of 183.36, its value comes out to be 13.54. its value is 13.54. yeah, 13.54. So now come to the problem. So firstly we set up the null hypothesis. So what is the null hypothesis? Null hypothesis means no change. So in this case we are given that the population mean IQ is 100 only. So it means that we are assuming that this sample has been drawn from the population where the mean IQ is 100 only. And what is the alternative? It is not equal to 100, right? So it is a two-tailed alternative. Two-tailed alternative. Now the next, because level of significance alpha is not given here, so we can choose the level of significance alpha as a 5%. So means we need to check the value of t at 5% level of significance, and degree of freedom is n minus 1. N minus 1 means 10 minus 1 is 9. So we are going to check its value at 5% level of significance and 9 degree of freedom. So we can refer the t table, but this time we are going to refer for two tail. Two tail means 5%. This is the 5%, and we need to check the value at 9 degree of freedom and 5%. Its value is 2.262. So its value comes out to be 2.262. This is the tabulated value, right? So now we are going to calculate its value using test statistics. So the test statistic t is equal to x bar minus mu upon s upon square root of n minus 1, because we have calculated the sample standard deviation, so we can use this formula. Okay, so x bar is 97.2, mu is 100, and s is 13.54 divided by square root of 9. So it is a minus 2.8 into 3 upon 13.54. Now one more thing, so this is the value we are given in the absolute form, because in two-tailed test means 2.5% from left hand side, 2.5% from the right hand side. So both are the region of rejection, this side one. Okay, so here we are getting the positive value, so this is basically the absolute value of t. Okay, means this side its value is minus 2.262, and this side its value is 2.262. So it means if the value falls in between these two, then this is the region of acceptance, and if the value falls outside this region, then this is the region of rejection. Okay, so its value is 3 2 cos 6, and this is minus 8.4 divided by 13.54. Clearly this value is less than 1. Still, if we calculate this value using the calculator, so it comes out to be 2.8 multiplied by 3 divided by 13.54. So its value is minus 0.62. So clearly this value falls within this interval between these two values. So it means that, what do we conclude? So because t calculated is minus 0.62, which falls in between minus 2.262 to 2.262, that is falls in the region of acceptance, so hence null hypothesis accepted. So what can we conclude from here? So it means that this sample has been drawn from the population with mean IQ 100. Okay, so this is the solution of this problem. Okay, so this is the first part of the question. Now the second part of the question is do this data support the assumption of population mean of 100? So in this case the answer is yes. Now the second part is find a reasonable range in which most of the IQ value of sample of 10 by slice. So what does it mean? So range means we need to find out confidence interval. So because here we have chosen 5% level of significance, it means that we are going to calculate 95% confidence interval. Okay, because like I told you now, if this is the 5% means 2.5% from this side, 2.5% from this side, so it means this is the 95%. So 95% confidence interval formula is x bar plus minus t alpha n minus 1 s upon square root of n minus 1. So this is the interval in which the value of mu will fall, right? Like in case of large sample test, I told you the value of mu belongs to x bar plus minus z alpha time s upon square root of n. So in this case we simply replace the test statistics z alpha with the t alpha n minus 1. The rest of the value will formula will remain same. Okay. So here x bar is 97.2 plus minus 2.262 multiplied by 13.54 divided by 9, sorry 3 square root of 9, because n minus 1 is 9, square root of n minus 1 is square root of 9, that is 3 only. Okay, so if we solve this particular part, so 2.262 multiply 13.54 divided by 3, so it is 10.21 approximately. So 97.2 plus minus 10.21. So it means that when I subtract 10.21 means it is 86.99, and when we add, then this is 107.41. So this is the interval in which most of the student IQ will fall. Okay, so this is the solution of this problem. Okay, so in case of small sample test, the first thing is the problems are always same. You need to identify that either this problem belongs to the small sample test or the large sample test. If the sample size is small, and for small sample the condition is population standard deviation is always unknown. This is the necessary condition. Okay, then we use t-test. Otherwise, if the sample standard deviation is known, then we preferably use normal test only. Okay, now come to the next part. Next part is the t-test for the difference of means. So difference of mean, basically t-test difference of means, there are two different type of the problems are there in this particular part. So the first one is in this case we are assuming that there are two independent samples. There are two independent samples with sample size n1 and n2, and say their sample mean is x1 bar and x2 bar, and their sample standard deviation is s1 and s2. This is the sample standard deviation. Okay, so what we want to test in this case, we want to test that either these two sample has been drawn from the same population with mean, say if its population mean is mu x and mu y. So our general assumption is that the sample has been drawn from the population whose mean is this, but the population standard deviation is the same. So this is the necessary condition whenever we want to apply the t-test for difference of mean, that both the sample has been drawn from the population whose variance is same. Okay, if this condition is not given, then firstly we need to test this particular one. So how can we test this? This we'll discuss in our next segment. That is the F test we use to check the equality of the variance. But in the problem of the t-test of difference of mean, we generally assume that both the sample has been drawn from the population whose variances are same. Okay, and what is the formula for the test statistics? The formula is same like I told you. It is the estimator minus expected value of the estimator upon the square root of variance of the estimator only. But in this case our estimator is a sample mean difference. Okay, and what is the expectation of x1 bar minus x2 bar? This is linearity property expectation of x1 bar minus expectation of x2 bar. This is say mu1 minus mu2. And the variance, now because they are independent, so variance of x1 bar minus x2 bar is variance of x1 bar plus variance of x2 bar. So it, in this case it is sigma 1 square upon n1 plus sigma 2 square upon n2. But because we are assuming that their population variance is same, so sigma square is taken outside, 1 upon n1 plus 1 upon n2. But because the population standard deviation is unknown in the cases of the small sample test, so in this case we have to use an unbiased estimator of sigma square. Okay, so in this case we are going to use the estimator as capital S square equal to 1 upon n1 plus n2 minus 1. This is the if you remember that the formula of S square is 1 upon n minus 1 summation xi minus x bar square. So what is the value of this one? This is n minus 1 time n1 minus 1 time s1 square plus n2 minus 1 time s2 square, right? So because s1 expectation of s1 square is equal to sigma square, and expectation of S2 square is equal to sigma square, because both are unbiased estimator of population variance. So this they will become, when we take the expectation, then this will be equal to 1 upon n1 plus n2 minus 2. So n1 minus 1 times sigma square plus n2 minus 1 times sigma square. So sigma square is taken outside. We have n1 plus n2 minus 2 upon n1 plus n2 minus 2. They will cancel out. So it means that this is the unbiased estimator of the population variance sigma square. But because in this case we have taken the two different samples, so one sample size is n1, another sample size is n2. So in this case the total degree of freedom will be their sum, n1 minus 1 plus n2 minus 1. So it is n1 plus n2 minus 2. So these are the total degree of freedom we have for the testing of hypothesis. Okay, so now let us come to the problem based on the t-test for the difference of mean. Okay, let us come to the first problem here. So the question is, sample of 2 electric light bulbs were tested for the length of the life and the following data were obtained. So sample size is given, sample mean, sample standard deviation is given here. Is the difference in the means sufficient to warrant that type 1 is superior to type 2 regarding the length of the life? So what is the null hypothesis? Null hypothesis, we are saying that no difference, means population means. Okay, what is the meaning of null hypothesis? Null hypothesis means there is no significant difference between their population mean. But what is the alternative hypothesis? It states that the type 1, if I say that its population mean is mu1, its population mean is mu2, then mu1 should be greater than mu2, means their difference is greater than 0, means there is a significant difference in their population mean. Okay, now level of significance, we are assuming alpha equal to 5%. So we need to, and what about the degree of freedom? This is n1 plus n2 minus 2. So n1 is 8, n2 is 7, so it is 13. So we need to check the value of t at 5% level of significance and 13 degree of freedom, and it is a right tail, so it is a right tail alternative. Right tail alternative. So we are going to refer the t table for 11 degree of freedom. 11 degree of freedom is this one, and one tail test. 11 degree of freedom, and one tail means the 5% level of significance, means its value comes out to be 1.796, not 11, sorry, basically 13. Its value is 1.771 because it's a 13 degree of freedom. 1.771. This is the tabulated value. Okay, now we need to calculate the test statistics. So what is the test statistic? T is equal to x1 bar minus x2 bar minus mu1 minus mu2 upon capital S time square root of 1 upon n1 plus 1 upon n2. Okay, so what is x1 bar? X1 bar is 1234, x2 bar is 1036, mu1 minus mu2, because our assumption is this is 0, so it is 0. Now what is the formula of S square? This is n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, or n1 minus 1 capital S1 square plus n2 minus 1 time capital S2 square upon n1 plus n2 minus 2. Okay, because the relation between small s and capital S is, capital S square is n small s square upon n minus 1, right? So I can multiply this side, so this is the relation here. Okay, so because sample standard deviation is given, small s1 and small s2 is given, so we are using this formula to calculate capital S square. Okay, so firstly we calculate capital S square and then we substitute its value in this formula. So what is the formula of capital S square? N1, that is 8 into S1 square. S1 square is 36 square and 40 square. 36 square plus 7 times 40 square upon 8 plus 7 minus 2. So this value comes out to be, let us use the calculator. So 36 square multiply 8 plus bracket 40 square multiply 7 bracket close divided by 13. This value comes out to be 1659.0769. And what about its square root? So the value of capital S comes out to be, if we take its square root, 40.7317, approximately 43.732. This is the approximate value. So if we substitute this value 43.732 into 1 upon 8 plus 1 upon 7, so this is 198 upon 43.732 into 1 upon square root of 1 upon 8 plus 1 upon 7. Okay, so what I need to do, I need to multiply this term with bracket reciprocal of 8 plus reciprocal of 7 bracket close its square root and then equal to, its value is 21.08. so 198 upon 21.08. so if I divide this number, or I take the reciprocal and multiply it with 198, then its value comes out to be 9.39. so this value comes out to be 9.39, but the tabulated value is 1.771. okay, and it is a right tail test. Right tail test is the critical value is 1.771, and this side we have a region of rejection, and the value falls this side because 9.39 is T calculated is 9.39, which is greater than 1.771. so it means that T calculated falls in the region of rejection, hence null hypothesis rejected. Okay, so what can we conclude here? So we can conclude from here that alternative hypothesis is true. It means that type 1 bulb is superior than type 2 bulb. So it means that type 1 is superior than type 2 bulb in terms of the length of the life, regarding the length of the life, right? Regarding the length of the life. Okay, so in this case we are given all the data is completely given to us. We simply need to decide firstly the null hypothesis means no difference, alternative hypothesis type 1 is superior than type 2. The rest is the formula of the T statistic for difference of mean, where we have two independent samples, and then after calculating we can get the desired result. Okay, let us consider the another problem. Okay, in this question the height of 6 randomly chosen sailors are this, and those of 10 randomly chosen soldiers are this. So we are given two sample, n1 is given here 6, n2 is given here 10, Discuss the light that these data thrown as suggestion that sailors are on average taller than sailors. So let mu1 is the population mean of sailors, and mu2 represent the population mean of soldiers. So what will be the null hypothesis? There is no difference in their height, no change. And what is the alternate hypothesis? That the height of the sailor is more than the average height of the soldiers, means mu1 is okay. And level of significance alpha is 5%, and the total n1, the degree of freedom will be n1 plus n2 minus 2, so it is 6 plus 10 minus 2, that is 14. So we need to check the value of t at 5% level of significance and 14 degree of freedom. Now again in this case it is a right tail alternative, okay. So if we refer the t table for 14 degree of freedom, 14 degree of freedom and 5% level of significance, its value is 1.761. This is the value of the calculated value of t. So now the next step is we need to calculate the test statistic. So what is the test statistic here? T is equal to x1 bar minus x2 bar minus mu1 minus mu2 upon capital S into square root of 1 upon n1 plus 1 upon n2, where capital S square is n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So mu1 minus mu2 is 0, so the value of t will be x1 bar minus x2 bar, and because this term is 0, okay. So firstly we need to calculate the sample mean of these two data. So what we have done, I have simply collected this data in the Excel file and we have calculated their mean. This is the data of sailors and this is the data of the soldiers. So we have calculated that if we simply take the sum of all these values, comes out to be 408. How many sailors are there? 6. So if I divide 408 by 6, then it is 6 ka 36, 6 ka 48. So its mean comes out to be 68 only, right? And we know that what is the formula of variance? Variance is 1 upon n summation xi minus x bar square. So I firstly calculate x minus x bar. This is basically x minus x bar, and then we have calculated x minus x bar square. So its sum comes out to be 60 only. So 1 upon 6 into 60, its value comes out to be 10. This is the variance of S1, right? S1 square. And what is x1 bar? It is 68. Now in the second case we have calculated the sum, its value comes out to be 67.8. So what is the mean? Mean x2 bar is 678 by 10, so it is 67.8. And what about the variance? So for variance, what we have done, I have simply considered in this case we know that variance is independent of shifting of region. Variance of x plus a is same as variance of x. So we have shifted the origin, we have calculated its deviation about the point 68 only, and then we have calculated this one. So we assume this as z. So what is the formula of variance of z? This is 1 upon n summation z square minus z bar square. So when we calculated their sum, its sum comes out to be minus 2. Okay, so what is the formula? 1 by 10 154 minus 2 by 10, it's a square, so its value is 15.4, and this square is 0.2 square is 0.04, so answer is 15.36. so this is the variance S2 and this is the variance S1 square. So if I use this particular value, so what is the value of capital S square? N1 S1 square plus N2 S2 square upon N1 plus N2 minus 2. So N1 is 6, S1 square is 10, N2 is 10 and its value is 15.36 divided by 6 plus 10 minus 2, that is 14. So it is 60 plus 153.6 upon 14. So this is 213.6 divided by 14. So if we calculate it, 213.6 divided by 14, so its value is 15.257, and if we take its square root, it is 3.906. 3.906. So what is the value of capital S? 3.906. So what is the value of T? X1 bar is 10 and X2 bar is X1 bar is 68, it is 67.8. 68 and 67.8. minus 0 upon 3.906 into 1 upon 10 plus 1 upon 6. So it is 0.2 divided by 3.906 into, if I multiply simply this particular term with reciprocal of 10 and the reciprocal of 6, bracket close, its root, and then we multiply, its answer comes out to 2.07. so its value comes out to be 2.07. 2.017 basically. Okay, and if I take the reciprocal and multiply with 0.2, so its value is approximately 0.1. yeah, its value is approximately 0.099 with a negative sign, no, positive only, right? Now but the calculated value of T is 1.761, and this is the calculated value and this is the tabulated value. So what does it mean? If we apply the right tail, so the critical value is 1.761 and the calculated falls in the acceptance region. So because T calculated is 0.099, which is less than 1.761, so it means that T calculated falls in acceptance region. Hence null hypothesis accepted. Null hypothesis accepted. What do we conclude from here? That there is no significant difference between the average height of the soldiers and sailor. The average height of the sailors and soldiers, hence the result. Okay, so in this case we are again given a data. Firstly, with the help of the data, we have calculated the mean and sample variance of both, and then with the help of that we have calculated the pooled sample variance, and then substituting this value in the formula of the test statistics, we can get the value of calculated value of t, compare it with the tabulated value, and because the value falls in the acceptance region, so null hypothesis accepted. Okay, now let us consider the another one. Okay, the question is to test the claim that the resistance of the electric wire can be reduced by at least 0.0 ohm by allying 25 values obtained for each allied wire and standard wire. So test 5% level whether or not their claim is substantiated. Okay, so what will be the claim here? The claim is that the resistance of the electric wire, so let mu1 represent the resistance of the standard wire, and the resistance of the electric wire can be reduced by at least 0.05 ohm by allying. So when this is the standard wire and this is the allied wire, or you can consider this is the allied wire and this is the standard wire. So when we allied, then this resistance is reduced by 0.05. So it means that their difference is at least less than or equal to 0.05. Minimum resistance reduced by 0.05. Okay, so less than or equal to means it is basically a composite hypothesis, right? In a very first video of the basic definition, we have discussed what is a composite and a simple hypothesis. When instead of a single point we are given a range, that kind of hypothesis is called a composite hypothesis. Okay, and what about the alternate hypothesis? No, it is greater than 0.05, means it is not reduced, rather it will increase, right? Okay, so it is the their claim is not substantiated, right? Claim is not substantiated. Okay, so the level of significance is given here, alpha as a 5%, and the sample size both are given as 25. So n1 is given here as 25, n2 is given also as a 25. So the degree of freedom will be n1 plus n2 minus 2. So 25 plus 25 minus 2 is 48. Now you can see here it will exceed 30. So when the sample size is greater than 30 or the degree of freedom are more than 30, then t distribution tends to normal distribution only. So what can we do? We simply compare its value with the normal distribution at 5% level of significance, and its value is 1.645 in case of right one tail test, right? Okay, so now what is the test statistic? The test statistic will be t is equal to x1 bar minus x2 bar minus mu1 minus mu2 upon capital S into square root of 1 upon n1 plus 1 upon n2, where capital S square is 1 upon n1 plus n2 minus 2 time n1 s1 square plus n2 s2 square. Okay, so to calculate this particular part, okay, okay, there is a, I think so in this case their claim is the resistance is reduced by at least 0.05 ohm, but the null hypothesis means there is no difference. So we are saying that there the difference is 0.05 only, right? And the alternate hypothesis is this will reduce by 0.05, right? Okay, so in this case if I substitute this value, because all the data is given to us, because null hypothesis means that we are saying that there is no difference. It means that we are simply saying that the allied wire, when we the resistance of the electric wire is reduced by 0.05 ohm, but it's saying at least means that its value is reduced more by 0.05 ohm. Okay, so x1 bar is given as 0.0, so basically here it is a left tail alternative, so its value is minus 1.645. so x1 bar is 0.083, x2 bar is 0.136, and mu1 minus mu2, its value is given as 0.05 upon n1 s1 square. So firstly we need to calculate the value of capital S square. What is capital S square? n1 into s1 square. s1 is 0.003 square plus 25 times 0.002 square upon n1 plus n2 minus 2. So now 25 is common, so 3 square is 9, 9 into 10 raised to the power minus 6, and 4 into 10 raised to the power minus 6 upon 48. So this is 25 into 13 into 10 raised to the power minus 6 upon 48. So if I calculate this value, so 25 multiplied by 13 divided by 48, and then we take its square root. Its value is 2.602 multiply 10 raised to the power minus 3. This is the value of capital S, and then we need to multiply it with square root of 25, 2 by 25. 2 by 25 and its root. Its value comes out to be 0.736 approximately. Its value is 0.736. So what is the value of t? Comes out to be t is equal to 0.083 minus 0.136, right, 0.136 minus 0.05 upon 2. Its value comes out to be 0.736. So it is the 0.05 means 0.186, 0.083, 0.005 or 0.05, 0.05. Okay, so 0.05. okay. So its value is 0.083 minus 0.186. So 0.083 minus 0.136 minus 0.05 equal to divided by 0.736. So answer comes out to be minus 0.1399, minus 0.1399. okay. But in the denominator we have a 10 raised to the power minus 3 also. So 10 raised to the power minus 3 means we need to multiply it with 10 raised to the power 3. So its value comes out to be minus 139.9. So this value is very much, this is the t calculated, minus 1.39.9, but T tabulated value, which is equal to Z at 5% level of significance, its value is minus 1.645. So this value is much bigger than this one because it is a left tail test. So this is the critical value 1.645. So minus 1.398 falls in the region of rejection. So T calculated falls in the region of rejection. Hence null hypothesis rejected. So what do we conclude here? So it means that his claim is substantiated, means whatever he is claiming that the resistance is reduced, that claim is correct. Okay, so it means that his claim is correct that the resistance is reduced by 0.05 ohm, hence the result. Okay, so so in this particular part we have discussed the problem based on small sample test and the difference of t-test also. Now I am going to discuss some MCQ type problems based on this particular, whatever the topic we have covered so far. Basically it's a mixed problem. Okay, let us come to the first question. The first question is the average growth of a certain variety of pine tree is 10.1 inches in 3 years. A biologist claimed that a new variety will have a greater 3-year growth. A random sample of 25 of new variety has an average growth is 10.8 with standard deviation 2.1 inch. At 5% level of significance, the null hypothesis is. Okay, so what is the null hypothesis? Means no change. The average growth is 10.81 inches per year per 3 years, right? And what is the alternate hypothesis? It is greater than 10.1, right? So it is a one tail, right tail. Alpha is given here 5%, so we need to check the value of T at 5% level of significance. And what is the sample size here? N is 25, so degree of freedom will be N minus 1, that is 24, because sample size is less than 30, because 25 is less than 30, so we are using small sample test. So let us refer T table for 24 degree of freedom and 5% level of significance. 5% means its value is 1.711. Okay, so now we calculated the t-test statistics. This is equal to x bar minus mu upon s upon square root of n minus 1. X bar is given here 10.1. No, x bar is given at 10.8. X bar is given as 10.8 and mu is given as 10.1. And the sample standard deviation is given here as 2.1 divided by square root of 24 and minus 1. So it is 0.7 into square root of 24 upon 2.1. Okay, so if I multiply 0.7 with square root of 24 and divided by 2.1, its value is 1.63. Now clearly this value is smaller than, because it is a right tail test. 1.711 is the critical value, this is the acceptance region, and this is the rejection region. So because the value 1.63 falls in the acceptance region, so it means that we are going to accept the null hypothesis because the calculated value of test statistics is less than the appropriate critical value 1.711. So the correct answer is option C only. Okay, let us come to the next question. Different varieties of fruits and vegetables have different amount of nutrients. The difference are important when these products are used to make baby food. We wish to compare the carbohydrate content of two varieties of peach cheese. The data were analyzed with GMP and basically in this case they are simply comparing and making the they have applied a t-test for difference of mean, right? So they have taken the two different varieties of fruit and to check the nutrients. So they have we wish to compare the carbohydrate content of the two variety of peaches. Okay, so the data were analyzed with GMP. They have used some software to analyze the data and they have got this output. So estimate is given as 4.2636, standard error is given as 3.1366, degree of freedom is 10. So what is the test statistics? So test statistic is basically estimated value upon the standard error, right? Like I told you, what is t? X bar minus mu. This is the estimate upon the standard error, right? So estimate is given as 4.2636 and standard error is given as 3.1366. so if I simply take the ratio of these two, so we can get here 4.2636 divided by 3.1366, 1.359. so it means the correct answer is option A only. Okay, so in this case they have already given the data in the tabular form, so they have used some software to calculate the value. Estimate is also given here, which is the numerator part, and the standard error is also given here, which is the denominator term. So what is the answer? So answer is simply the ratio of these two. Okay, now let us come to the next question. A simple random sample of size 16 is drawn from a population with 50 members. So n is given here 16. Simple random sample of size 16 is drawn from a population with 50 members. What is the standard? Okay, the population size is 50 and the sample size is 16. What is the standard error of the sample mean if the population variance is known? So population variance is also known, so we want to find out the standard error. Like I told you, when the population variance is known, then the standard error is always sigma upon square root of n, right? Otherwise we use t estimate x bar minus mu, but in that case the condition is population standard deviation is unknown, then we use capital S upon square root of n, because capital S square, expectation of capital S square is sigma square. But if population variance is known, then we use sigma in place of S only. So what is sigma? It is 5. What is square root of 16? That is 4. So 5 upon 4, its value comes out to be 1.25. So what is the value of the standard error? 1.25 only. Okay, what is the standard error? Standard error is the standard deviation of the sampling distribution statistic. Okay, so hence the answer is 1.25. Come to the next question. In a study of iron deficiency among infants, random sample of infants following different feeding program were compared. One group contained breastfed infants while the children in the another group were fed by a standard baby formula without any iron supplement. Okay, so we are given the two set of the infants, their sample mean and standard deviation is given. So the question is, we want to find out the confidence interval for the difference of mean. So what is that? x1 bar minus x2 bar plus minus, because the sample size is small, so t at alpha level of significance, alpha by 2, n minus 1, n1 plus n2 minus 2 time standard error. Standard error is capital S into square root of 1 upon n1 plus 1 upon n2. Okay, so what is x1 bar minus x2 bar? X1 bar is 13.3, x2 bar is equal to 12.4, so their difference is 0.9. so this is 0.9. in all the four option 0.9 is there. Okay, so next is 2%. 2% means 1% from each side, so we are going to check the table for 1%. 1% means 0.01 from the right hand side, so 0.99. okay, so for two tail, otherwise for two tail also it is given here. So 1% its value is for two tail 2%. 2% level of significance for how many degree of freedoms are there? So degree of freedom will be 18 minus 2, n1 plus n2 minus 2. These are the degree of freedom. So this is 10 plus 8 minus 2 is 16. 16 degree of freedom, and level of two-tail test 16, its value comes out to be 2.583. 2.583 into capital S square is equal to n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So if we calculate 1.7 square multiply by 8 plus bracket 1.8 square multiply by 10 bracket close equal to divided by 16, and then we find out its square root. It is 1.86 multiply by 2.583. So it is 4.811. Okay, we need to multiply by square root of reciprocal of 8 plus reciprocal of 10 bracket close, its root 2.823, 2.28. So it is 0.9 plus minus 2.28. Okay, answer should be 2.28. Maybe here we have a, instead of this, your answer should be 2.28. This is the correct answer. Or because in certain condition they are using n1 minus 1, like I told you, in certain books they are using the sample standard deviation as a capital S1 only. Okay, so if we use that particular formula, then we can use 1.7 square. Let me cross check the answer. 1.7 square multiply by 7 plus 1.8 square multiply by 9 equal to divided by 16. Then we take its square root and then multiply it with 2.583 and then multiply by reciprocal of 8 plus reciprocal of 10 bracket close. Multiply by okay, it means that there is a problem in the printing only, so it should be 2.28. okay, so this is how we can calculate the confidence interval. 98% confidence interval means 1% from both sides, 1% from this side and 1% from this side, so total is 2% only. So in this case the tabulated value for 2% means two tail, 2% we are considering here, that means 1% from both the side. So in that case its value comes out to be 16 degree of freedom, it is 2.583. okay, so we have used this particular formula here and multiplied with capital S into square root of 1 upon n1 plus n2. That will gives us the required answer. Okay, come to the last question. If X has a normal distribution with mean 1 and variance 4, then this particular one has normal distribution, standard normal distribution. Okay, basically it is given that x follow normal distribution with mean 1 and variance 4, but here we have a x square, so I can rewrite this as 1 by 4 x square minus 2x plus 1 as x minus 1 whole square upon 4. So here mu is equal to 1 and sigma square is equal to 4, so I can write it as x minus mu whole square upon sigma square. So this is x minus mu upon sigma whole square. So this will follow chi-square distribution with 1 degree of freedom. Okay, so what is this? So the correct answer is the square of the standard normal variate always follow, because x minus mu upon sigma follow normal distribution with mean 0 and variance 1, and its square will follow chi-square distribution with 1 degree of freedom. So the correct answer is option D only. Okay, so I have included some question from all the different topic in the testing of hypothesis. You can just try this particular one. If you still find out any doubt or inquiry, you can post your query in the comment section. I'll try to provide you the solution of the same. Just revise it. Thank you and have a nice day.